Welcome to Driven. I'm your host, Paul Perrone. We're going to learn and talk about AI, robotics, autonomous vehicles, and so much more. Check us out at driven.show on the web and give us a thumbs up or subscribe here if you like the show. So kick back or buckle up and become driven. Hi, I'm Paul Perrone, and welcome to the 10th episode of Driven. I've been offline a little bit here. I moved my studio and all of the equipment around, and it was just utter chaos. So a little bit of a lag between the last episode and this episode as I sort of regrouped and got things working again, but I'm back. And in this episode, it's going to be an informational episode. I'm going to sort of build upon what I think we covered in the 6th episode, which was what is an AV map? And I'm going to talk a little bit about how an AV plans its mission, sort of given this map. So you might recall from episode 6, or you can go and review episode 6 if you'd like. And we covered all the elements that really go into a map that an autonomous vehicle looks at to kind of determine where to go. The map. So the map defines a number of lanes that the vehicle can travel along and lanes that it needs to be aware of, that there's a sequence of typically high definition waypoints that define the lane and perhaps its boundaries, unless it's given like a lane width and a series of waypoints, intersections, stop signs, various kinds of other map features that the vehicle may be interested in, such as where it can pick people up and drop people off, destinations, if you will, and also other aspects of the map, such as open zones, parking lots, and anything that you or I might want to consider when we're determining where we can travel in a city, in a suburb, or some area in which we're operating. So now, given a map, the vehicle needs a mission. What's its end destination? Is it just one location that it has to get to? Is it a number of intermediate checkpoints? Is it going to go to point A, point B, and then C, or just to some end destination? That essentially, in as simple terms as possible, defines the mission for the vehicle. Now, there may be other aspects of the mission, such as when you get to checkpoint B, perform a certain activity, such as allow people to board the vehicle, allow people to get off the vehicle if it's a passenger vehicle. If it's a logistics type vehicle, it may involve sort of instructing the vehicle at that point to perform a hitching maneuver, to hitch to some trailer, or unhitch and leave a trailer behind, or dump the contents of what may be in the bucket of a dump truck, for example. So there's other sort of directives that can be embodied in a mission file or a mission directive that tell the vehicle what to do when it gets to each sort of intermediate checkpoint or the ultimate destination to where it's going. Now, give it a map and give it a mission. A vehicle can, or the system can generate a route. What is the sequence of roads the vehicle is going to travel down to get to those checkpoints or ultimately that end destination? Basically, that's the route planning or the route generation facet of these autonomous vehicles. Now, in some applications, that can be done on board, or it can be done off board. You may have an onboard sort of route planning mechanism where the vehicle, has its maps on board, and either an operator enters in a mission or a human being through a ride-sharing app will say, "Hey, here's where I want to go," and then the vehicle dynamically plots its route, or it may be given to it from some sort of central dispatch computer or ride route planning mechanism that's somewhere in the cloud or somewhere on a server room, or through some dispatch system. And then given that route generation, you ultimately end up with a series of very often waypoints that define those waypoints along the map that it's going to navigate to, each step of the way. Ultimately, the sequence of waypoints that the vehicle needs to hit to ultimately get to the checkpoints and the destination that it's trying to get to based on the generated route. Then there's different ways to plan this route, different, you might call them cost functions, to basically determine what's the optimal route for this vehicle. It may be based on the shortest distance to the ultimate check destination or the checkpoints along the way. It may be max optimizing for time. What's the shortest amount of time involved based on the various speed limits that may be associated with the roads that the route has been generated for. And it could be based on other factors too, like what's the least amount of energy for like an electric vehicle, for example, that could be expended along the way. Or if there are other features of the map, such as these are charge points or charge locations that the vehicle needs to hit along the way. If those are some of the checkpoints for its mission, it may be also sort of varied to consider those factors as well, such that it hits certain locations, such that it will be able to recharge either automatically or perhaps manually as it's navigating its mission to its ultimate destination. Sort of depends on how big the route and ultimate route plan is that's generated as to whether or not such a consideration is required. But there's all kinds of other cost functions that can be considered. The idea is, what is that cost function? Is it time, minimizing based on time? Is it minimizing based on miles traveled? Is it energy consumed, or is it something else like avoidance of tolls and minimizing an actual dollars and cents type cost in that fashion as well? Now, there are different algorithms for achieving this. One, popular algorithm that we're familiar with, for example, is called the A-star algorithm, which builds up this network of nodes and applies whatever cost function you give it to minimize and just goes through in some algorithmic fashion a series of looks at this network of different nodes to minimize based on the cost that it gives for each transition from node to node, and finds the lowest lowest number as it sort of navigates this network of possible paths to the ultimate destination. So, for example, if you're at point A and you want to get to point D, which is your destination, and you can navigate along one path, which brings you to a point B, or navigate to another path, which brings you to a point C, and the distance from point A to point B is 1, and the distance from B to D is 1, but the distance from A to C is 2, and the distance from C to D is 2. The cost of using the intermediate node C is going to be 4, and the cost for using the intermediate node B is 2. And since that's the lowest cost, it will pursue the route that includes node B, for example. And so now imagine a much more complicated route with hundreds and thousands of such nodes. These algorithms have a way to recursively sort of go down different options and then find sort of the lowest cost path to the ultimate destination. And again, those costs could be distance, it could be time, it could be an actual dollars and cents cost if there's energy involved. Energy consumption is a consideration, or tolls and things like that. So, but really, that's it in a nutshell. This is not unlike any other route planning mechanism that one might engage with if you're using Google Maps or Apple Maps or some other mapping utility with your onboard GPS device. It's going through a similar process, but in this case, for autonomous vehicles, it's doing the same thing and figuring out what its route or path should be. So, but a couple important things, I guess, distinctions with autonomous vehicles again is how it gets this ultimate route. Is it something that is generated onboard through some onboard operator or rider who's selecting their destination? Is it done via an app where someone selects their destination and some back-end dispatch system is planning the routes and doling them out to the vehicles? That's another possibility. Then there's also dynamic route planning. If the vehicle in the process of traveling to the end destination encounters a blocked route, you have to replan and regenerate essentially the route that the vehicle is going to travel down. So you may start from where you ended up, where you have sort of a blocked path and where you're prohibited from traveling any farther, and replan from based on that intermediate point to the end destination that you're trying to get to, or the next checkpoint, and find the minimum cost from that point to that destination, and maybe block off virtually in the map representation that you have that portion of the map where you previously thought you could get from wherever you were stuck at to the next waypoint now is blocked, and you may mark that temporarily blocked, or some central dispatch system may tell you that it's blocked or unblocked, if there's such a system in place to kind of keep track of routes, especially if you've got a shared network of information across different automated or connected vehicles in such an environment. So there you go. That's how an AV plans its mission. Now, in the future, I'm going to keep these informational episodes a little shorter, such that we can have more information in a more digestible format. The conversational episodes that we'll have in Driven will be as long as the conversations take. Typically 1 to 2 hours so far to date is pretty much the level of tolerance that people have for talking with me. And but we'll be talking to you or seeing you soon in the next episode, be it a conversational or informational episode here on Driven. Thanks very much. I hope you enjoyed the show Driven with me, Paul Perrone, your host. Don't forget to check us out at driven.show on the web, and give us a thumbs up or subscribe here if you like the show. Thank you for listening in. See you soon.